Hi everyone. In this given problem statement, we have to convert a sorted array to a binary search tree. We are given an integer array of nums where the elements are sorted in ascending order. Convert it to an height balanced binary tree. Height balanced is very important because if it is not given right, let us take this example. What I can do, let's say I can take minus 10 on the left side, right? Because if it's a binary tree, right, on the left hand side it's or the left child is always going to contain the number which are smaller, so I can put null out here, and on the right side I could put minus 3, 0, 5 and 9. So here, right, it's been clearly stated that we have to create an height balance tree. So how to do it? Let us take this example. Minus 10, minus 3, 0, 5 and 9. So out here, right, we are going to have two pointers. Left would be pointing to 0 right now, and the other one 5. So we are going to find the mid. So mid is going to be L plus R double divided by 2 to get an integer point. So it would be 2. So 2, this would be the mid. So once we got the mid, right, so on the left child, right, what we're going to do, so this is going to be our root. So 0 would be the root in this case. Now on the left child, right, so we are going to put our right pointer out here, and then we are going to find the mid. So it would be 0 plus 1 double divided by 2, which is basically going to be 0. So our mid in this case, right, is going to be 10. Okay. So here, right, after that, right, if I shift it again? So I cannot, because I have to give a base condition where if L is less than R, we have to return the value. Means this would be our base condition, right? So here, right, we are able to find the mid or our root, right? If it was 0 plus 1 double divided by 2, right, it would be 3. So it would be coming out in this position, and again from here the other value would be minus 10. And similarly, right, I can point my left pointer because see, this would be on the left side and this is going to be on the right side. Okay, so here my tree would become this 4 plus 5 double divided by 2, which is going to be 4.5. I can take 9 out here. So 9 would be the value and the other one would be 5. If I code it up, right, how it's going to look, I can create a helper function def helper, which is going to take the left and right values. I can say if L is greater than R, then I can return. Else I can say, I can call the root equal to tree node. Tree node would be the Python function, and I have to calculate the mid. So mid equal to L plus R double divide by 2, and it would be nums of mid, and then root dot left. Here I'm going to do divide and conquer, so I'm going to call my helper back again, and here I'm going to pass in. So here, right, our left is going to remain the same and right would be mid minus 1, and similarly root dot right. helper, and it would be mid plus 1 and right, and I can return my root. And the time complexity of it would be big of n because you're traversing the entire thing, even though you're using recursion, but it would be linear time. And I can call the helper with 0 and length of nums minus 1. So if I pass in with length of minus 1, right, the value would be 4. So in this way you have to write it. Now let me write the Python code, and I think which is going to make the things even more clearer. The first thing that you're going to do, right, we are going to create our helper function, or I can say DNC, divide and conquer. Here it will be L and R. If L greater than R, then I can simply return. Else I can say I have to find the mid, so mid equal to L plus R double divided by 2. Let me give in some brackets to make it readable. And here I can say root equal to tree node to create my binary tree, nums of mid, and root dot left is going to be helper L comma mid minus 1, and root dot right equal to helper mid plus 1 and R. And at last I can return my root. And let me call it, or let me say return helper 0 and length of nums minus 1. Let me run the code. I hope it should work. Yeah, I made one spelling error. It would be tree node. Let me run it back. As you could see, the public test case is passed. Let me submit the code. The code got submitted and it is beating 100% of the submission. So it's a pretty efficient solution. That's all for this video. See you in the next one.